Hi. In this video, we will look at how to design an API flow in Astera Data Stack. An API flow is an artifact used to design a data or function service endpoint, incorporating various data connectors, transformations, quality checks, task-based operations, integrating services, and more. Astera Data Stack holds the ability to create an API flow as an API endpoint by defining its request and response objects. To start, let's see how we can create API flows within a project. Navigate to the main toolbar, select Project, hover over New, and select a project. API flows can only be deployed from a project. Once the project is created, head to the Project Explorer panel. Right-click on any of the folders in the project, hover over Data Services, and select Add New API. By default, your API flow file will contain two required objects, request and response. These act as start and stop objects for an API flow. This flow will be saved with a .api extension. The request object is used to define the request endpoint resource, input parameters, and message payloads expected from the API user, which would then be used in the flow processing. To start, right-click on the object and select Properties from the context menu. The parameter configuration window will open. Here, you can define all the expected parameters from the request. We can see multiple fields, such as the name, parameter location, data type, and more. The parameter description is what will be used in the auto-generated Open API Swagger specification. The required checkbox is selected if the parameter must be included for a request to be valid. The API returns a 400 bad request error response if the required parameters are not provided. Once done, we will select Next, and the API configuration screen will appear. If we look at the API configuration screen, we can see a location that states the HTTP method. Through this, we can select which method operation we want to use for the request object. There are 5 methods based on which the request object can be configured. The method depends on the resource operation happening in the flow. These options are get, delete, post, put, and patch. For this demonstration, we will be configuring a GET API flow. There are multiple areas to configure here. The resource becomes a part of the request URL. The example URL displays a complete request URL formed with the appended resource and parameters. The published description is a description of the API operation on the given resource. There are 2 checkboxes below. If we enable the Show Advanced Fields checkbox, it will display additional fields in the Request Info node. The Show User Context Fields checkbox will display user profile fields from the incoming request in the Request Info node, if enabled. An API flow can be processed in 2 ways, synchronously and asynchronously. To learn more about the 2 processing types, please refer to our documentation site. For our use case, we are using the GET method to find order items by order ID. We will click OK, and our request object will be configured using the GET method. Under the Request Info node, additional fields will appear depending on which checkbox is selected in the API configuration window. Next, we will be configuring the response object. An API endpoint flow begins with a request object and ends at one of the many responses defined in accordance to the flow execution route. To start, we will right-click on the object and select Properties from the context menu. The response configuration window will open, and here we can specify the HTTP status code to be returned. The mapped content layout allows us to map a pre-serialized response string and its content type as input to the response object. Custom layout allows us to build a layout on the next screen based on the content type defined. We can define custom layouts of the following types. Once done, we will click Next. In this window, we can define the output layout of the response object. There are 3 ways to map the output layout. We can do this manually by defining objects and fields. We can use a sample text, which will open a new window where a sample text, based on the content type defined, is given to generate the layout accordingly. And finally, we can generate a default layout, which can be used to output an error and any additional messages. If we click on this option, the box will be populated automatically. Once done, we will click Next, and the Output Parameters window will appear. Here, we can define header parameters to be returned as part of the response. This is the pagination screen that allows us to set a form of pagination on the response data. To learn more about pagination, please visit our documentation site. Selecting the Enable Cursor Pagination option is going to enable cursor pagination on the data payload returned, and the page size determines the size of a page in cursor pagination. The empty response section lets you define custom responses for various status codes, such as 404 and 200. Once done, we will click OK to close the configuration window. The response object has been configured. The body node will show the output layout hierarchy that has been configured within the properties. If we expand the response info node, it will display additional information that can be mapped to an output to be processed further in the test flow. Expanding the headers node will show any headers that have been defined within the object. Since we have now configured the request and response objects, we can map them together and use them in a flow. This API flow feeds the input order ID to a database lookup and returns the output in the response. This is how you can design an API flow with Astera Data Stack. For more information on Astera Data Stack, please visit our documentation site. Thank you for watching.